In this video, you'll learn what Docker is, why we need it, and how containerization works, explained in easy terms.
So Docker overview. So this is one idea that we had discussed, that once we are having a single server, on that we are maintaining multiple applications. And now suppose developer has installed one version of MongoDB, he has installed one version of JS and some other things. And now the testing team also wants to test that same thing. So they will have to maintain the same versions of all the software on their system also. Okay. Only then the testing can be done. Otherwise, the code can break because of difference in the environment. So that was the challenge. Okay. So as you can see that as we uh, come from very start, we were using bare metal servers. So we will be installing operating systems on the servers itself. That was the first level. That level was somehow solved by the virtual machine, where we can have a single server on which we can have multiple virtual machines. We could even take a image snapshot of a virtual machine. Say developer can take a image snapshot of a virtual machine, give it to the software tester, and he can just create a new virtual machine using that image. Okay, so that solved a problem to some extent, but it's still, as we said, that it was difficult because virtual machine size was bigger, right? So the resources that virtual machine was consuming was more. So still the problem remained, and this is the main problem that we are trying to address. So Docker came in. So Docker is what? It's a containerization platform. It simply is allowing you to package the application that you have created and whatever dependencies you need from the system together. This concept is called containerization. Okay. And what it means is that now you don't have to worry about the environment. So you can have a container, you can put it into different machines. It will work seamlessly. The only catch is that a Linux container will not work on a Windows container, and vice versa. Or I should say, a container created in a Linux environment will not work in a Windows environment, but within Linux it can work. Okay. Uh, so what containers do is they share the host kernel, and it makes them lightweight and faster. So what we can achieve out of containerization? Uh, so suppose we have to create an application, right? If you remember the example, we will create an HTTP server. We will have a MySQL database. So in a normal scenario, what you did was on your the same virtual machine, you installed MySQL, you installed HTTPD, you installed Samba, and now when you go further, then there can be other development going on. So you will keep on installing them on your virtual machine or your Linux machine or on your Windows machine, whatever it is. What containerized does is that instead of uh, just using MySQL or JavaScript implementation directly on the machine, you first of all containerize it. Okay, so for every service that you are using, for every application that is required for you to set up for your setup, you will containerize it. You will do a networking among these containers. So now this becomes a portable thing. Okay, so run each service within OAuth dependencies inside separate containers. That is what we do today. Even in Exotel, that will happen on your server side. Okay, so this is called containerized applications. Now you can just move them to one machine to different machines at your will without breaking anything. So it is not like we will create a single container with all the applications. No, we will not do that. Each service with its libraries, with its dependencies, will become a separate container. So on one server at a given point of time, you may be running 5 containers, 6 containers, and so on. Now someone can ask, what is a container again? Container is a standard unit of software that packages up the code and all its dependencies so the applications runs quickly and reliably from one computing environment to another. Again, a simple definition of it. You can also have OS containers. Okay. OS containers are virtual environments that share the kernel of the operating system but provide user space isolation. For all practical purposes, you can think of OS containers as VMs. You can install, configure, and run different applications, libraries, etc., just as you would do on any OS. Just as a VM, anything running inside a container can only see resources that have been assigned to that container. Okay, so this is also possible. that you actually today it's a very normal thing, right? To have a OS container also, and it can be different flavors also. Okay, so like similar way you do a Docker image pull of Nginx, you can also do a Docker image for Ubuntu or something else that you can get. Not a big deal at all. So basically, what we are saying is these OS containers actually, again, what they do is they share the kernel of the base operating system, but they are providing a separate user space isolation. Okay, so again, in this OS containers, kernel part won't be there. Kernel they will be using from the base OS only. Uh, that's why they are also lightweight. So they will not take more than 2 seconds or maybe a minute to install and get up running. Okay, but you have installed OS, it takes an hour to install, right? Or 30 minutes to install. That will not happen in these cases once you try it, because the bulk of the thing they are already using from the base operating system.
Hit the bell icon and subscribe to our channel for more such videos.